In defining motional EMF, I've spoken about the work done by force, QV cross B, and yet since force is perpendicular to the velocity, we know that it does no work on the particle. So there's a paradox here. But we can resolve this, but it's quite an involved calculation. This is just a shortcut way of explaining it. Because this QVB is actually the force, or the magnetic force, is pushing the charges up this conductor here from B to A, from here to here. These themselves cause their own magnetic force. The magnetic field pointing in the page here, and we've got this charge going upwards, so the magnetic force will be right to left. If the velocity is going up and the magnetic field is going in that way, if we cross the velocity vector here with the magnetic field, then we're obviously going to go this way here. We're going to be that way. So we're going out. So we're going from, you can see here, I've drawn it here, we're going from right to left. But B here is still going into the page, so the magnetic force will be right to left, okay? So because of the Hall effect, an electrostatic force will be produced in opposite direction, which can be proved to equal the work done in the original EMF from B to E. So this work done is in fact due to the Hall effect. So there's no paradox in the end. The fact that they're perpendicular, the velocity and the magnetic field are perpendicular, and you know there can be no work done. But this is actually resolved by remembering that there's a Hall effect happening at the same time. So that's why that weird paradox seems to appear. It's not actually a paradox at all. It's the fact that when these charges are moving, they're also producing their own magnetic force, which by the Hall effects causes electrostatic to push in the opposite direction.